All right. Oh, put that there. Put this here. Do this. And then
How much on average does each man eat and how much each woman eats? And you say, well, what about the children? You say, well, in our kingdom, the king says, in our kingdom, we forbid potato chips for children. And you say, oh, well, that's all and good. Well, tell me what happened at the previous parties. And so the king says, you might remember at the last party, in fact, the last two parties, we had 500 adults. At the last party, 200 of them were men, 200 men, and 300 of them were women. 300 were women. And in total, they ate 1,200 bags of potato chips. 1,200 bags of potato chips. And you say, what about the party before that? And he says, that one we had a bigger skew towards women. We only had 100 men, 100 men, and we had
401.
400 women. 400 women. And that time we actually had fewer bags consumed, 1,100. 1,100 bags of potato chips. So you say, okay, king and arbegla, this seems like a fairly straightforward thing. Let me define some variables to represent our unknowns. So you go ahead and you say, well, let's let m equal the number of bags eaten
Two.
eaten by each man, and you could think of it on average, or maybe everyone in all the men in that kingdom are completely identical, or just maybe this is the average number of bags eaten by each man. And let's let W equal the number of bags eaten by each woman. Each woman. And so with these definitions of our variables, let's think about how we can represent this first piece of information, this piece of information in green. Well, let's think about the total number of bags that the men ate. You had 200
200.
you had 200
200
men.
M.
200, let me scroll over a little bit. You had 200 men and they each ate
300 M.
m bags.
W
M bags per
equals
man.
1200.
So the men at this first party collectively ate 200 times m bags. If m is 10 bags per man, then this would be 2,000. If m was 5 bags per man, then this would be 5,000. We don't know what m is, but 200 times m is the total eaten by the men. Same logic, total eaten by the women is 300. 300 women times the number of bags eaten by each woman. And so if you add the total eaten by the men and the women, you get the 1,200 bags. You get the 1,200 bags. So this is this information written algebraically given these variable definitions. Now let's do the same thing with the second party, the information that they gave us right over here. Let's think about how we can represent this algebraically. Well, similar logic. What was the total that the men ate at that party? It was 100 men times m bags per man, and we're assuming that m is the same across parties, that men on average always eat the same number of bags. And how many did the women eat at that second party? Well, you had 400 women, and on average they ate W bags per woman. So this is how 400 times W is the total number that the women ate. You add those two together, you have the total number that all the adults ate. So this is going to be 1,100 bags. So it looks pretty similar now. You have a system of two equations with two unknowns, and so you try your best to solve it. But when you solve it, you see something interesting. Last time it was very convenient. You had I think it was a 500 here for 500 adults, and you had another 500, and so it seemed like it was pretty easy to cancel out one of the variables. Here it seems a little bit more difficult.
No.
What's multiplying by the m's, it's different here. The coefficient on the w is different over
Times
here.
by negative
You
2.
say, well, maybe I can change one of these equations so it makes it a little bit easier to cancel out with the other equation. So what if, for example, I were to take this blue equation right over here and multiply it by negative 2. And you might say, well, Sal, why are we multiplying it by negative 2? Well, if we were to multiply it by negative 2, this 100m would become a negative 200m. And if it was a negative 200m, then that would cancel out with a positive 200m, when we add the two. So let's see what happens. So let's just multiply. Let's multiply this blue equation by -2. We're going to multiply by -2. Let me scroll over to the left a little bit. So what happens? Remember, when we multiply an equation, we can't just do one term. We have to do, and we can't just do one side of the equation. We have to do the
W
entire
equals 2.
equation in order for the equality to hold true. So -2 times 100m is -200m. -2 times 400w, and there's a positive right over here, so it becomes -800w. And then -2, now we did the left-hand side, but we also have to do the right-hand side. -2 times 1100 is -2200. So just to be clear, this equation that I just wrote here essentially has the same information. We just manipulated. We just changed this equation, multiplied both sides by -2. But it's kind of the same constraint. But what makes this interesting is now we can rewrite this green equation. Let me do it over
M equals
here.
3.
This first one. 200m.
Some men ate 3
200m
bags and women ate 2
plus
bags.
300w is equal to 1200. And the whole reason why I multiplied by -2 is so that if I were to add these two things, I might be able to get rid of that variable over there. And so let's do that. Let's add the left-hand sides and let's add the right-hand sides. And you could literally view it as we starting with this blue equation. These parties, we're assuming that that's both sides.
2 and 3.
Thought was a difficult problem using the magical, mystical
3.
Let's solve a few more systems of equations using
A
elimination.
12-minute video.
But in these, it won't be a kind of a one-step elimination. We're going to have to massage the equations a little bit in order to prepare them for elimination. So let's say that we have an equation 5x minus 10y is equal to 15. And we have another equation, 3x minus 2y is equal to 3. And I said we want to do this using elimination. Once again, we could use substitution. We could graph both of these lines and figure out where they intersect. But we're going to use elimination. But the first thing you might say, hey, Sal, with an elimination, you are subtracting the left-hand side of one equation from another, or adding the two, and then adding the two right-hand sides. And I could do that because it's essentially adding the same thing to both sides of the
I forgot how to do substitution. I don't think I did. X equals -4y. I forgot how to do this. So it's going to be 2 times -4. I need to get it. So 2 times -4y. Okay. I think we got it. Y, so it's going to be 7x minus 3 times 5x minus 4 20. 7x minus 15x minus plus 12. X equals -1. So if x equals -1, so it's 5, if -5 minus 4, y equals -9. Uh, yeah. Yeah. Uh, 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 uh. -7 times -3y plus 8 minus 6y equals 4. Plus 56. It's gonna be 60. 15, 30, 45. 4. Y equals 4. 4, 8, 12. So -12 plus 8 is -4. Ooh, I don't feel like doing this one. -4x plus 7 times 3. 21. And then 7 times 15. I just don't know the answer to that one. 105. Equals. Oh, fuck, I got distracted. Equals 20. So, it's gonna be 85. -85 equals 17x divided by 17 divided by 17. 85, right? Oh, I feel this is wrong. Whoa, 17 goes into 85. Yeah, 5 times. X equals -5. So if x equals -5, -15 plus 15, y equals 0. Booyah. Yes, sir. Yes, sir. Yes, sir. Dude, look at all these videos. Jesus Christ.
Sides of the equation. But here, it's not obvious that that would be of any help. If we added these two left-hand sides, you would get 8x minus 12y. That wouldn't eliminate any variables. And on the
Multiply by
right-hand side, you would just
5.
be left with a number. And if you subtracted, that wouldn't eliminate any variables. So how is elimination going to help here? And the answer is we can multiply both of these equations in such a way that maybe we can get one of these terms to cancel out with one of the others.
-5.
So let's say we want, and you could really pick which term you want to cancel out. Let's say we want to cancel out the y terms. So I'll just rewrite this 5x minus 10y here. 5x minus 10y is equal to 15. Now, is there anything that I can multiply this green equation by so that this -2y term becomes a term that will cancel out with the -10y? So I essentially want to make this -2y into a positive 10y, right? Because if this was a positive 10y, it'll cancel out when I add the left-hand sides of this equation. So what can I multiply this equation by? Well, if I multiply it by -5, -5 times -2 right here would be positive 10. So let's do that. Let's multiply this equation times 5, times -5. So you multiply the left-hand side by -5 and multiply the right-hand side by -5. And what do you get? Remember, we're not fundamentally changing the equation. We're not changing the information in the equation. We're doing the same thing to both sides of it. So the left-hand side of the equation becomes negative 5 times 3x is
Y equals
negative
0.
15x.
Y
And then
equals
negative
0.
5 times negative
X
2y
equals
is
1.
plus 10y is y. That was the whole negative 10, both sides by negative 10. And we are left with
Whoa,
y
whoa, 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 whoa.
is equal to 3x minus 2.
Why did I get this wrong? Oh. Oops. Oops. I know why. I didn't even do the fucking. I just did 15x. I didn't add them. Negative 10. X equals. Holy shit.
15. Multiply this green equation by so that this negative 2y term becomes a term that will cancel out with the negative 10y. So I essentially want to make this negative 2y into a positive 10y, right? Because if this was a positive 10y, it'll cancel out when I add the left-hand sides of this equation. So what can I multiply this equation by? Well, if I multiply it by negative 5 times negative 2 right here would be positive 10. So let's do that. Let's multiply this equation times 5 times negative 5. So you multiply the left-hand side by negative 5 and multiply the right-hand side by negative 5. And what do you get? Remember, we're not fundamentally changing the equation. We're not changing the information in the equation. We're doing the same thing to both sides of it. So the left-hand side of the equation becomes negative 5 times 3x is negative 15x. And then negative 5 times negative 2y is plus 10y is equal to 3 times negative 5 is negative 15. And now we're ready to do our elimination. If we add this to the left-hand side of the yellow equation, and we add the negative 15 to the right-hand side of the because if this was a positive 10y, it'll cancel out when I add the left-hand sides of this equation. So what can I multiply this equation by? Well, if I multiply it by negative 5, the yellow equation, we are adding the same thing to both sides of the equation because this is equal to that. So let's do that. Let's do that.
Okay, so I see.
0. Divide both sides by negative 10. Both sides by negative 10. And we are left with y is equal to 15 over 10 is negative 3 over 2. So if you were to graph it, the point of intersection would be the point 0, negative 3 halves. And you can verify that it also satisfies this equation. The original equation over here was 3. To massage the equations and literally pick on one of the variables or another. It doesn't matter. You could say, oh, let's eliminate the y's first. But I'm going to choose to eliminate the x's first. And so what I need to do is massage one or both of these equations in a way that these guys have the same coefficients, or their coefficients are the negatives of each other, so that when I add the left-hand sides, they're going to eliminate each other. Now, there's nothing obvious. I could multiply this by a fraction to make it equal to negative 5. Or I could multiply this by a fraction to make it equal to negative 7. But even a more fun thing to do is I can try to get both of them to be their least common multiple. I could get both of these to 35. And the way I can do it is by multiplying by each other. So I can multiply this top equation by 7. Let me multiply this top equation by 7. And I'm picking 7 so that this becomes a 35. And I could multiply this bottom equation by negative 5. By negative 5. I negative 5. And the reason why I'm doing that is so that this becomes a negative 35. Remember, my point is I want to eliminate the x's. So if I make this a 35, and if I make this a negative 35, then I'm going to be all set. I can add the left hand and the right hand sides of the equations. So this top equation, when you multiply by 7, it becomes, let me scroll up a little bit. When you multiply by 7, it becomes 35x plus 49y is equal to, let's see, this is 70 plus 35 is equal to 105, right? 15 at 70 plus 35 is equal to 105. That's what the top equation becomes. This bottom equation becomes negative 5 times 7x is negative 35x. Negative 5 times negative 3y is plus 15y, right? The negatives cancel out. And then 5, this isn't a minus 5, this is times negative 5. 5 times negative 5 is equal to negative 25. Now, we can start with this top equation and add the same thing to both sides, where that same thing is negative 25, which is also equal to this expression. So let's add the left-hand sides and the right-hand sides, because we're really adding the same thing to both sides of the equation. So the left-hand side, the x's cancel out. 35x minus 35x. That was the whole point. They cancel out. And on the y's, you get 49y plus 15y. That is 64y. 64y is equal to 105 minus 25 is equal to 80. Divide both sides by 64. Divide both sides by 64, and you get y is equal to 80 over 64. And let's see, if you divide the numerator and the denominator by 8, actually, you could probably do 16. 16 would be better. Well, let's do 8 first, just because we know our 8 times tables. So that becomes 10 over 8. And you can divide this by 2, and you get 5 over 4. If you divided just straight up by 16, you would have gone straight to 5 over 4. So y is equal to 5 over 4. Let's figure out what x is. So we can substitute either into one of these equations or into one of the original equations. Let's substitute into the second of the original equations, where we had 7x minus 3y is equal to 5. That was the original version of the second equation that we later transformed into this. So we get 7x minus 3 times y times 5 over 4 is equal to
That's what I
5.
got.
Or 7x minus 15 over 4 is equal to 5. Let's add 15 over 4. Oh, sorry, I didn't do that right. This would be 7x minus 3 times 4. Oh, sorry, that was right. What am I doing? 3 times is 15 over 4. 15 over 4 is equal to 5. Let's add 15 over 4 to both sides. So plus 15 over 4.
Holy shit, hold up. Why is it his y? Where the fuck did you get 25?
Plus 15 over 4. And what do we get? The left-hand side just becomes a 7x. These guys cancel out. And that's going to be equal to 5 is the same thing as 20 over 4. 20 over
Why did they cancel out? Oh,
4 plus 15 over 4. Or we get that
where the fuck did you get the 20 over 4?
4 plus 15 over 4. And what do we get? The left-hand side just becomes a 7x. These guys cancel out. And that's going to be equal to 5 is the same thing as 20 over 4. 20 over 4 plus 15 over 4. Or we get
Whoa. Oh, this guy's doing some wizards. How the fuck? Oh, did I get X? It's the same thing as Y. Am I stupid? Did that by 3, 15, and 7. 49. Huh.
that. Let me scroll down a little bit. 7x is equal to 35 over 4. We can multiply both sides by 1/7, or we could divide both sides by 7. Same thing. Let's multiply both sides by 1/7. The same thing as dividing by 7. So these cancel out, and you're left with x is equal to. Here, if you divide 35 by 7, you get 5. If you divide 7 by 7, you get 1. So x is equal to 5/4 as well. So the point of intersection of this right here is both x and
What if I want to multiply? So, no, I want to divide. Yeah. So divide by 7. So in order to divide,
5/4 as well. So the 4, what do you get? It should be equal to 15. So this is equal to
I want to play Fall Guys so bad. I want to play Fall Guys. Dun, dun, dun. Aye, aye, Captain. I can just multiply. Huh, I don't have to do anything. These cancel, so y equals 24y equals 0. Y is going to be 0. You can't 0 divided by whatever 0. Since y is 0, I can just do 2x divided by 24, 2, 4, 6, 8, 10. So that's going to be 10, 12. Excuse me. These cancel as well. 14x equals negative 14. 14x divided by 14 is going to be negative 1. X equals negative 1. Y equals, so it's 10. No, so it's 5 minus 5, so it's negative 10. 10 divided by negative, no, negative 10 divided by 10, negative 1 as well. I was trying to do it in my head. No, what did I do wrong? So it's going to be 14x equals negative 14 divided by 14 divided by 14. X equals negative 1. Plug x back into it, so that's where I got it wrong. Oh, yeah. It's gonna be negative 5 plus the other side is 0. Anything divided by 0, so y equals 0. Derp, derp, derp. X cancel out. 13, 14, 15, 17. Y equals 17. Y equals 14. Y equals 14 over 17. I don't like that fraction. Whatever. Y equals 14. And then x. Oh shit. 5 times 14 over 17 plus. No, what the fuck am I doing? Y. 5x plus 4 times 14 over 17 equals 24. So 14 times 4, 56. 17 is a prime number. 3, 4, 5, 6, 12, 7, 14, 8, 16, 9, 18. Yep. 5x plus 56 equals. Oh, 56 over 17, right? 24. 4 times 14. Where's the division? Nope. I don't know. This one's weird. What the fuck? I did the fucking math wrong. I'm so fucking stupid. I was doing multiple. 7, 14, 21. It's 24. No wonder. 17 over 17. Yeah, it's 1. 4 and 1. Oh, I'm me so stupid. Y's cancel out. That's gonna be 16x. 80 divided by 16. 5. 5. 5y. So if I add, it's gonna be 35. Minus 35. Minus 35. 8y equals. So that's gonna be 110. Whoa. So what can go into this number? What the fuck? Yeah, -5. If I want to do for this one. Oh, it was -5. Ah, I see what I did wrong. I forgot it was negative. I did positive. I don't care, I'm not doing that again. Stupid mistakes, that's what happened. That's what happened. Let's get some music in. So what can I do? Let me multiply. Honestly, 3. I can just multiply 14x plus 5y equals 31. 2x minus 3y equals 29. Multiply the bottom by 5. Multiply the top by 3. That's gonna be 14 times 3, 42. X plus. Okay, so now this cancels. x equals negative 1. Y equals. So this one equals x equals negative 1. So negative 2 minus 2 plus 2. 9, 18, 27, y. 9. What can I solve it with? Just multiply the top by 4. Yeah. So multiply by 4. So 4 times negative 4 is negative 16. Oh, no, I have to multiply by negative 4. Negative 4 times negative 4 is 16. 16y plus negative 4 times 7 is 28. X equals 9 times 4. Negative 1 times 6. Okay, so 16s, they cancel. Negative 28 plus 9 is going to be 18. 18, 19, negative 19. X equals 196 plus minus 40. Can be negative 133. 5 by 19. 7. X equals 7. So if x equals 7, 7 times 7 is 49. So 49 minus, this is going to be 0, so y equals 0. Yes, mental man. Just actually, I can divide. I'm gonna divide the top. The top, I'm gonna divide it by. Actually, right at the bottom. Get the y, so divide the top by 2. Yeah. Okay. Oh, divide by 3. Divide the bottom by 2. Negative 6 divided by 3 plus negative 1 to negative. Negative 6 divided by negative 3 is 2. Why? Minus. Oh, I don't want to divide anymore. Never mind, I don't want to divide. I just multiply. Multiply the top by 4, multiply the bottom by 6. Multiply the top by negative 4 though. 24y. 4x. Negative. And then 5. positive 36 44 over 44. Damn, x equals negative 144. Yeah, seems kind of high. So if x equals negative 144, I think I messed up my math. Oh, negative. So 0. So x equals 0. So if x equals 0, that's 0. Negative 6 divided by 36 divided by negative 6 is 6. Positive 6. Oh, good thing I called that. And what I can do is just multiply the bottom by 2. So it's going to be negative 10x minus 14y minus 38? 38. Okay, so the x's still cancel out. Negative 14 minus 3, 17 is negative 17. Y. Plus minus 100. 0 plus 100. Oh, yikes. The fuck? Y equals. I think this one's wrong. Oh my gosh, yeah, I did something wrong. Hold up. Okay, let me just write everything out. 10x. Let me actually write 10. Plus equals 81. And then this one, I would just write 5x minus 7y equals 19. Multiply the bottom by 2. So it's going to be negative 10x minus 14y equals negative 38. X cancels. Y is going to be 14. Negative 17. Y equals 81 minus 38. 43. Okay, so the answer can be y equals negative 43 over 17. That's weird. So I'll do the bottom one. So negative 5x negative 7 times negative 43 over 17 equals 19. So 7 times 43 equals 301. I don't know how to do this one. What? This doesn't explain shit. Yeah, so you get 10x minus 14y minus 38. Eliminate the x as follows. Yep. So equals 0 minus 17 minus 119. How the fuck does y equals negative 7? Negative 7? Oh. 6 negative. I need a new piece of paper. Running low. What is the result of adding these two equations? The result is gonna be 3x equals 14. 3x equals 14. And what can I do here, eh? Eh? Write it out. 4, 5, x, 0, 2y plus 5, x, I can multiply the bottom by 2. So it's gonna be 4y. Wait. 4y plus 10x minus 38. These cancel. 21x minus 105. x equals 5. X equals 5, that means multiply the top equation by 1/2. It's gonna be 5x. Nope. Multiply the bottom equation by 2. X. Yep, like this one. Add the equation. Minus 10. How do you add the equation? Oh, what? Oh, I didn't see the Y. I was only focusing on the S. X. Oh, I got it right. Whew. How can we get system B from A? Oh, B. So what did they do? They did nothing. Kind of loud. Y equals -3. -3. I don't know this. Is this 6 or 0? Let's see. 0. Oh, let's do 6. Because if I do -3. That's 0. Then 31 divided by. What up? X is 3. No. I don't know. Yeah, y equals -3. 6. I knew it was 6. What the fuck? Why did I put 3? That crosses 9y equals 3. If y equals -3, that means x is 4, 8, 12. -12 plus 6 is 18. -2. Yeah. Fuck, dude, this is a lot of videos, man. Serious.
The king's advisor, Arbegla, is watching all of this discourse between you, the king, and the bird, and he's starting to feel a little bit jealous because he's supposed to be the wise man in the kingdom, the king's closest advisor. So he steps in and says, okay, if you and this bird are so smart, how about you tackle the riddle of the fruit prices? And the king says, yes, that is something that we haven't been able to figure out, the fruit prices. Arbegla, tell them the riddle of the fruit prices. And so Arbegla says, well, we've want to keep track of how much our fruit costs, but we forgot to actually log how much it cost when we went to the market. But we know how much in total we spent. We know how much we got. We know that 1 week ago, when we went to the fruit market, we bought two pounds of apples. We brought 2 pounds of apples and 1 pound of bananas. 1 pound, I guess I can, 1 pound of bananas. And the total cost that time was $3. So there was a $3 in total cost. And then when we went the time before that, we bought 6 pounds of bananas, 6 pounds of apples, I should say. 6 pounds of apples and 3 pounds of bananas, and the total cost at that
$9.
point was $15.
Whoa.
So what is the cost of apples and bananas? So you look at the bird looks at you, the bird whispers into the king's ear, and the king says, well, the bird says, well, just start defining some variables here so we can express this thing algebraically. So you go about doing that. What we want to figure out is the cost of apples and the cost of bananas per pound. So we set some variables. So let's let A equal the cost of apples per pound, and let's let B equal the cost of bananas per pound. So how could we interpret this first information right over here? 2 pounds of apples and a pound of bananas cost $3. Well, how much are the apples going to cost? Well, it's going to cost 2 pounds times the cost per pound times A. That's going to be the total cost of the apples in this scenario. And what's the total cost of the bananas? Well, it's 1 pound times the cost per pound. So you're just going to have B. That's going to be the total cost of the bananas because we know we bought 1 pound. So the total cost of the apples and bananas are going to be 2A plus B. And we know what that total cost is. It is $3. Now let's do the same thing for the other time that we went to the market. 6 pounds of apples, the total cost is going to be 6 pounds times $1 per pound. And the total cost of bananas is going to be, well, we bought 3 pounds of bananas, and the cost per pound is B. And so the total cost of the apples and bananas, this scenario, is going to be equal to 15, is going to be equal to $15. So let's think about how we might want to solve it. We could use elimination, we could use substitution, whatever we want. We could even do it graphically. Let's try it first with elimination. So the first thing I might want to do is maybe I want to eliminate, let's say I want to eliminate the A variable right over here. So I have 2A over here, I have 6A over here. So if I multiplied this entire white equation by -3, then this 2A would become a -6A, and then it might be able to cancel out with that. So let me do that. Let me multiply this entire equation, the entire equation times -3, times -3. So -3 times 2A is -6A. -3 times B is -3B. And then -3 times 3 is -9, is -9. And now we can essentially add the two equations, or add the left side of this equation to the left side of that, and the right side of this equation to the right side of that. We're essentially adding the same thing to both sides of this green equation, because we know that this is equal to that. So let's do that. Let's do it. So on the left-hand side, 6A and 6A cancel out. But something else interesting happens. The 3B and the 3B cancels out as well. So we're just left with 0 on the left-hand side. And on the right-hand side, what do we have? 15 minus 9 is equal to 6. So we get this bizarre statement. All of our variables have gone away, and we're left with this bizarre, nonsensical statement that 0 is equal to 6, which we know is definitely not the case. So what's going on over here? What's going on? And then you say, what's going on? And you look at the bird, because the bird seems to be the most knowledgeable person in the room, or at least the most knowledgeable vertebrate in the room. And so the bird whispers into the king's ear, and the king says, well, he says that there's no solution, and you should at least try to graph it to see why. And so you say, well, the bird seems to know what he's talking about, so let me attempt to graph these two equations and see what's going on. And so what you do is you take each of the equation, and when you graph it, you like to put it in kind of the y-intercept form or slope-intercept form. And so you do that. So you say, well, let me solve both of these for B. So if you want to solve this first equation for B, you just subtract 2A from both sides. If you subtract 2A from both sides of this first equation, you get B is equal to -2A plus 3. Now let's solve this second equation for B. So the first thing you might want to do is subtract 6A from both sides. So you would get, I'll do it right over, let me do it right over here. You would get 3B is equal to -6A plus 15. And then you can divide both sides by 3. You get B is equal to -2A plus 5. So the second equation, let me revert back to that other shade of green, is B is equal to -2A plus 5. And we haven't even graphed it yet, but it looks like something interesting is going on. They both have the exact same slope when you solve for B, but they seem to have different, I guess you could call them B-intercepts. Let's graph it to actually see what's going on. So let me draw some axes over here. So that is let's call that my B-axis, and then this could be my A-axis. And this first equation has a b-intercept of positive 3. So let's see, 1, 2, 3, 4, 5. The first one has a b-intercept of positive 3, and then has a slope of negative 2. So you go down, or you go to the right one, you go down 2. Go to the right one, you go down 2. So the line looks something like this. I'm trying my best to draw it straight. So it looks something like that. And now let's draw this green one. This green one, our b-intercept is 5, so it's right over here. But we have the exact same slope, a slope of negative 2. So it looks something like that right over there. And you immediately see now that the bird was right. There is no solution because these two constraints represent or can be represented by lines that don't intersect. So the lines don't intersect. They don't intersect. And so the bird is right. There's no solution. There's no x and y that can make this statement equal true, or that can make 0 equal 6. There is no overlap between these two things. And so something gets into your brain. You realize that Arbegla is trying to stump you. And you say, Arbegla, you have given me inconsistent information. This is an inconsistent system of equations. Inconsistent, which happens to be the word that is sometimes used to refer to a system that has no solutions, where the lines do not intersect. And therefore, this information is incorrect. We cannot assume that the apple or banana, either you're lying, which is possible, or you accounted for it wrong, or maybe the prices of apples and bananas actually changed between the two visits to the market. At which point, the bird whispered into the king's ear and says, "Oh, this character isn't so bad at this algebra stuff." Arbegla starts to feel angry and embarrassed that he was shown up by you and the bird in front of the king. And so he storms out of the room, and then a few seconds later he storms back in. He says, "My fault, my apologies. I realize now what the mistake was. There was a slight, I guess, typing error or writing error. In the first week, when they went to the market and bought 2 pounds of apples and 1 pound of bananas, it wasn't a $3 cost. It was a $5 cost. It was a $5 cost. Now, surely, considering how smart you and this bird seem to be, you surely could figure out what is the per pound cost of apples and what is the per pound cost of bananas. So you think for a little bit, how is there now going to be a solution? So let's break it down using the exact same variables. You say, well, if A is the cost of apples per pound and B is the cost of bananas, this first constraint tells us that 2 pounds of apples, so 2 pounds of apples are going to cost 2A, because it's $8 per pound, and 1 pound of bananas is going to cost B dollars, because it's 1 pound times B dollars per pound, is now going to cost $5. Is now going to cost $5. This is the corrected number. And we saw from the last scenario, this information hasn't changed. 6 pounds of apples is going to cost 6A, 6 pounds times $8 per pound, and 3 pounds of bananas is going to cost 3B, 3 pounds times B dollars per pound. The total cost of the apples and bananas in this trip we are given is $15. So once again, you say, well, let me try to solve this maybe through elimination. And once again, you say, well, let me cancel out the a's. I have 2a here, I have 6a here. If I multiply the 2a here by negative 3, then this will become a negative 6a, and it might be able to cancel out with all of this business. So you do that. You multiply this entire equation. You can't just multiply one term. You have to multiply the entire equation times negative 3 if you want the equation to still hold. And so we're multiplying by negative 3. So 2a times negative 3 is negative 6a. b times negative 3 is negative 3b. And then 5 times negative 3 is negative 15. And now something fishy starts to look like it's about to happen. Because when you add the left-hand side of this blue equation or this purplish equation to the green one, you get 0. All of these things right over here just cancel out. And on the right-hand side, 15 minus 15, that is also equal to 0. And you get 0 equals 0, which seems a little bit better than the last time you worked through it. Last time we got 0 equals 6. But 0 equals 0 doesn't really tell you anything about the x's and y's. This is true. This is absolutely true that 0 does definitely equal 0. But it doesn't tell you any information about x and y. And so then the bird whispers in the king's ear, and then the king says, well, the bird says you should graph it to figure out what's actually going on. And so you've learned that listening to the bird actually makes a lot of sense. So you try to graph these two constraints. So let's do it the same way. We'll have a b-axis. We'll have a b-axis. That's our b-axis. And we will have our a-axis. And let me mark off some markers here. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So this first equation right over here, if we subtract 2a from both sides, I'm just going to put it into slope-intercept form, you get b is equal to negative 2a plus 5. All I did is subtract 2a from both sides. And if we were to graph that, our b-intercept, when a is equal to 0, b is equal to 5. So that's right over here. And our slope is negative 2. Every time you add 1 to a, so if a goes from 0 to 1, b is going to go down by 2. So go down by 2, go down by 2. So this first white equation looks like this. If we graph the solution set, these are all of the prices for bananas and apples that meet this constraint. Now let's graph this second equation. If we subtract 6a from both sides, we get 3b is equal to negative 6a plus 15. And now we could divide both sides by 3. Divide everything by 3. We are left with b is equal to negative 2a plus 5. Well, this is interesting. This looks very similar, or it looks exactly the same. Our b-intercept is 5, and our slope is negative 2a. So this is essentially the same line. So these are essentially the same constraints. And so you start to look at it a little bit confused, and you say, okay, I see why we got 0 equals 0. There's actually an infinite number of solutions. You pick any x, and then the corresponding y for each of these could be a solution for either of these things. So there's an infinite number of solutions. And then but you start to wonder, why is this happening? And so the bird whispers again into the king's ear, and the king says, well, the bird says this is because in both trips to the market, the same ratio of apples and bananas was bought. In the green trip versus the white trip, bought 3 times as many apples, bought 3 times as many bananas, and you had 3 times the cost. So in any situation, for any prices of per pound prices of apples and bananas, if you buy exactly 3 times the number of apples, 3 times the number of bananas, and have 3 times the cost, that could be true for any prices. And so this is actually, it's consistent. This, we can't say that Arbegla is lying to us, but it's not giving us enough information. This is what we call, this is a consistent system. It's consistent information here. So let me write this down. This is consistent. This is consistent, and it is consistent. 0 equals 0. There's no shadiness going on here, but it's not enough information. This system of equations is dependent. It is dependent, and you have an infinite number. You have an infinite number of solutions. Any point on this line represents a solution. So you tell Arbegla, well, if you really want us to figure this out, you need to give us more information, and preferably by a different ratio of apples to bananas.
How do you draw that infinity? Oh. Eh, I think we're about to do
Is the system of linear equations below consistent or inconsistent? And they give us x plus 2y is equal to 13, and 3x minus y is equal to negative 11. So to answer this question, we need to know what it means to be consistent or inconsistent.
I think I know it. I figured it out. I have to use elimination or substitution. So I can just multiply the top by negative 2. Negative okay, so the x cancels, so it's going to be 10y minus, oh, okay, so you can't do that. Negative, so 0 equals 0. Infinitely many solutions. So if there's 0, so the top one's going to be negative 5y equals negative 3x plus 15 divided by negative 5. So it's going to be y equals 3 over 5x plus negative 3. So negative 3. Boop. 1, 2, 3. 1, 2, 3, 4, 5. The bottom one. There's 0. Negative 10y equals 6x plus 30 divided by negative 10. So y equals 246 3 over 5x minus 3. Oh, same shit. Should have known. Uh, whoa. Why? Yo, hold up. Why is there two Y's? Okay. 1 is going to be 1, 5, 2 is going to be 1, 2. So I'm going to multiply, do 3. Wait, if I do that, it's going to be 12. It's going to be, multiplied by -3, it's going to be -12 plus -9. So x and y cancel. And it's going to be 12, 24, 30, positive 36. That cancel. So it's going to be infinitely many solutions. And what I'll do is 9y equals -12x minus 36 divided by 9y equals 9, 18, 27, -4. Top one's -4 with 1, 2, 3, 4, 1, 2, 3. Bottom one's gonna be 3y minus here equals -4x 12. 3 divided by 3. Y equals -4 over 3 minus 4. Oh, same. Boop, boop. And then that and that. Yay! Yeah. Party. Sign in already. Why isn't it working?
inconsistent. So a consistent system of equations has at least one solution.
One intersect. What is this one? Okay. Did I skip? Okay. Dependent, independent, dependent. Oh. Okay. Dependent. Hmm. Blue green. Parallel. Independent. Independent. One solution. Infinite. No solution. One. Infinite. No solution. Inconsistent. Consistent. Consistent. Independent. Dependent. If you multiply this by -1, it's going to be -10 plus 2. This is no solution. So this one is independent. times -1. This is -5 plus 9. Cancel, cancel. No solution. Times this by 2. It's going to be 6x minus 4 at y. To cancel. No solution. Oh, oops, I forgot. Infinite. So it's dependent. Yep. Equals -1. What's the solution? Whoa. Plus 2. Oh, minus 2 is 4. So 4/5. Oh, yeah, 4/5. X is 4/5 and y is 1. Yeah. Then alright, I've been just skimming through these. Okay. Infinitely. Infinite. This one will intercept. So I'm going to multiply the top one by 3, so it's going to be -6x. And multiply the bottom by 2, so it's going to be 6x. So they cancel. 4, 8, 12, 12, and 6. One solution. I multiply this by -1, so it's going to be -5 plus y. So it's going to be 0 equals Oh, -1. No solution. How many solutions? I need to. I can't do the mental right now with that one. Let me just divide. Maybe y equals 714 -2x plus 4. So it's the same thing infinitely. Da, 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 so if I multiply, let me just multiply this by -2. So it's going to be -6x minus 2 equals -16. Boom. Mental math. So how long are these? <coughs> 11x plus 40. What? In 40 years, Aaron will be 11 times as old as he is right now. So it's going to be his age plus 40. Nah, I don't get it. Four. That confused me. Jeez, dude, that's a lot. William is 4 times as old as Ben. So I'll do W for William, B for Ben. So William is 4 times as old as Ben. So it's going to be W times B. 12 years ago, William was 7 times as old as Ben. Holy shit. So it's going to be William times B4. No, 4B. William times 4B. 12 years ago, William was 7 times as old as Ben. I, I don't know, man. Ben's age. B times 4. Oh, what the fuck? 4B. I don't understand this one, man. Three times, so Armand is 18. Dia is 2 years. How many years will it take for Armand to be 3 times as old as Dia? I don't know. Two plus one. Mm. Oh, I am gonna. Oof, I am gonna struggle. In 56 years, Kevin will be 9 times as old as he is right now. So is it 56 equals 9x? Oh, 56 years Kevin will be 9 times. So if he's 6, 6 plus 56, 62. I don't know how to do this. Let me just. Nope. 'Oh, I almost had it. I had 9k, 9x equals 56. I just forgot the. Ben is 12 years older than this. Ben and his son first met 2 years ago. 3 years ago, Ben was 4 times as old. What is it? I can't. It's just not clicking in my head. Ben is 12. Ben age plus 12. What? 3 years ago, Ben was B minus 3 years old, and Izzo was I minus 3. Ben was 4 times. Oh, okay, so 4 times. Bruh, I don't know. How would I never guessed? Why is this repeating? What? Oh. Ben is 12 years older than. Okay. So B equals 12 plus I. Three years ago, Ben was. I don't know, dude. Is almost 3 times as old as Christopher. So I equals 3 times C. And is also 14 years older than Christopher. So Chris equals I plus 14. I don't know how to solve this, dude. I equals 3C, yep. And I equals. It's on 3 times as old as Christopher. So he's on equals Chris's age times 3. And is also 14 years older. So is on equals Chris's age plus 14? Doesn't make sense. Because he's 3 times as older. William equals 4. How many years will it take until Aeson is only 5 times as old as William? So you do 72 equals, I don't know. 72y equals 4 plus y. Multiply that by 5. sense. Ben is 3 times as old as Daniel and is also 4 years older than Daniel. Plus 4. So Ben is 3D and Ben equals Where the fuck did you get B minus 4? I don't understand how to do this problem. Let's see. In 56 years, Daniel will be 5 times as old as he is right now. It's going to be D plus 56 times 5. 5 Why am I dividing? It's 56 times 5. 280. 56. Alright. How do you solve this? How do you? I know how to solve it. I just don't know how. Put it into an equation to solve it. I can solve it if it's an equation. But if it's not, I don't know how to solve it. Do I literally did not do that actually? 14. Oh shit. Yeah. Next question. No, I got water. Christopher is 20 years younger than his son. C equals I minus 20. 14 years ago, his son was 3 times as old as Christopher. Why did I write? Things messed up. Christopher is 20 years younger than his son. So it's going to be is I plus Chris plus 14 years ago. His son was I minus 14 years old. Christopher was C minus 14. I am getting pissed. How did I get that right? Just Dude, these age word problems are pissing me off. I'm gonna have to skip it. I think this guy gave up.